Welcome to a new session on number system. Today we will be discussing a very important topic on divisibility. Divisibility is a topic which is a fundamental topic to number system and becomes a basis of solving many questions in the competitive exam. So today we will be learning about divisibility of numbers from number 2 to 16. So to begin with, number 2, any number is divisible by number 2 if the last digit is divisible by 2. So if the last digit is 0, 2, 4, 6, 8, then the number is divisible by 2. For number 3, if the sum of the digits is divisible by 3, then the number is divisible by 3. So if we take a number 7, 5, 2, 4, 3, in this case the number, if we add these numbers, 7 plus 5 is 12, plus 2 14, plus 4 18, plus 3 21. So the sum comes out to be 21, which is divisible by 3. So the number is divisible by 3. If we take another number 7 5 2 4 8, in this case if we add the numbers, 7 plus 5 is 12, plus 2 14, plus 18, plus 8 26. So as 26 is not divisible by 3, then this whole number 75248 is not divisible by 3. So when we take number 4, if any number has last two digits divisible by 4, then that number is divisible by 4. So any numbers ending with 04, 08, 12, 16, 20, 24 and so on will be divisible by 4. When you talk about number 5, any number ending with 0 or 5 is divisible by 5. So any number other than ending with other than 0 and 5 is not divisible by 5. So 0 and 5 is what we look for divisibility by 5. So numbers we have discussed till now except 4 are prime numbers. So 2, 3, 5 were all prime numbers. So what are prime numbers? For this you can go and watch our video on prime numbers. The link is available and you can see on the icon button that is there. For number 6, which is not a prime number but a composite number. So what is a composite number? Composite number is a number which has factors. So 6 has two factors, they are 2 and 3. So any number to be divisible by 6 has to be divisible by 2 and 3. So what is the rule of divisibility of 2? That the last digit should be divisible by 2. So it can be 0, 2, 4, 6, 8, and for 3 we have learned that the sum of the digits should be divisible by 3. So if both these conditions are followed, then a number is divisible by 6. So now we will talk about number 7. Number 7 is again a prime number, and in this case what is required is we need to bunch the number into threes. So for example, if I take a number like 4537792, in this case from the right side we will start and we will divide them into bunches of 3. So first bunch of 3 and then the second bunch of 3. So here 792 plus 4 will be 796, and then we subtract the middle part of 537. So what do we get in this is 259, which is divisible by 7. Yes, it is divisible by 7, and we get this as 37, quotient as 37. So this number 4537792 is divisible by 7. This is how we check. The same rule applies for 13 also. In this case what happens is, in the above case we saw as if we find the difference, it was 259, but 259 when divided by 13 it doesn't give us a remainder 0. So in this case this number is not divisible by 13. So we will take another number. So we can take a number, for example 579488. Again we will follow the same rule. From the right side we will start and we will bunch in threes. So we will have 579 minus 488, and what we get is 91. So is 91 divisible by 7? Yes. Is 91 divisible by 13? Now we go again to number 8. 8 is a composite number, and in this case last 3 digits, if they are found to be divisible by 8, then the whole number is found to be divisible by 8. In case of 9, again the same rules, the sum of digits as in case of number 3. If sum of digits is divisible by 9, then the whole number is divisible by 9. In case of 10, if the last digit is 0, then if the last digit is 0, then a number is divisible by, then the number is divisible by 10. In case of 11, what we do, we take the number, the odd position in a number minus the even positions in a number, and if the difference is found to be divisible by 11, then the number is divisible by 11. So we'll take an example. So we'll take a number like 29435,417. So in this case the odd digits are 2 plus 4 plus 5 plus 1 minus 9 plus 3 plus 4 plus 7. So what do we get? 2 plus 4 is 6 plus 5 11 plus 12 minus 9 plus 3 is 12 plus 4 16 plus 23. So we get minus 11, which is divisible by 11. So this number is divisible by 11. Now we go to 12. 12 is again a composite number, and what are the factors for this composite number? The factors are 3 and 4. So if a number is divisible by 3 and 4, we know the rules of divisibility of 3 and 4, then the number is divisible by 12. 13 we have already discussed. You take a number, from the right side you bunch in threes, and then the bunches are to be, the difference has to be found out of the bunches. Difference of bunch of 3. That is how we come to the 13. 14, again a composite number with factors as 7 and 2. So if a number is divisible by 7, we know the divisibility rule of 7, bunching of 3 and then this difference of that, and 2 if the last digits are 0, 2, 4, 6 and 8, then it is divisible by 2. Now we go to 15. In case of 15, again a composite number, the factors are 5 and 3. So if the digit ends with 5, the last digit is 5 or 0, and the sum of the digits is divisible by 3, then the number is divisible by 15. For 16, last 4 digits should be divisible by 16. If they are, then the whole number is divisible by 16. So that is all on the divisibility. Now we will be doing some practice questions. So let's start with a practice.
How many 3-digit natural numbers? So it's a 3-digit natural number which is talked about. Without repetition of digits are there such that each digit is odd and the number is divisible by 5. So as we know, as we studied, that the divisibility of 5 is that the number should end with 0 or 5. Because each digit has to be odd, so the last number has to be 5 only. So this is fixed. So what are the remaining odd numbers available? They are 1, 3, 7 and 9. So these are 4. So the first place can be taken in 4 ways, and the second place can be taken, because repetition is not allowed, in 3 ways. So what is the total value that comes? 4 into 3 is 12. So the answer is B. Next, move to another question. What is the remainder when the number, which are multiples, is divided by 1261? In this case, we will see, first we need to identify 1261's factors and then identify them. So how can we find what are the possible divisible or factors of 1261? So remember, factor, if there is any factor to a number, it has to be less than or equal to its square root. So what is the nearest square root I can think of 1261 is 1225, which is a square of 35. So we have to try till 35. We may get much earlier also. So in this, what we will do, we will try to identify what are the possible factors available and nearby. So in this, what we will do, we'll start whether it is divisible by 2. No, we know the divisibility, last factor digit is 1. Divisible by 3. For this, we need to add numbers. 1 plus 2 is 3, plus 6 is 9, plus 1 is 10. So being 10, this is not divisible by 3. Then it is also not divisible by 9. Okay. Whether it is divisible by 4? No, because last two digits are 61. Not divisible by 4. Whether divisible by 5? No, because last digit is 1. It should be have been either 0 or 5. Whether divisible by 6? No, because it is not divisible by 2 and 3. Whether divisible by 7? Now that this is important, and how we can check? We need to do we 1 2 6 1, and as I told you, from the right side we'll start a bunch into threes. So 261 minus 1 is equal to 260. So this 260 is not divisible by 7, but it is divisible by 13. So 13 is one of the factors. So when I see 1261, so 13 is one of the factors, and I write 9, and it comes 117, and then it comes 91 and 97. So it is 13 into 97, and 97 is a prime number. So do we have 97 here? Yes, we have a 97 here. Now remains whether we have any number which is a multiple of 13. Yes, 91 is there. 91 can be written as 13 into 7. So 1261, which can be written as 13 into 97, has factors available in the above product. So this number is completely divides the above product. 1261 completely divides the above product, thus the remainder would be 0. Now we will move to next question. Which number among these is the smallest? So in this case, always try to identify and come to same platform or the same base. How can we come to the same base? 2 power 40 is 2 power 40. There is nothing more we can do in this. Again 3 power 21, because 3 is a prime number and we can't reduce down. 4 to the power 18, because 4 is a composite number, can be brought down to 2 to the power 2 into 18 is equal to 2 to the power 36. 8 to the power 12 can be written as 2 to the power 3 into 12 is equal to again 2 to the power 36. Now see, two values are same and we are asking for finding the smallest. And it is clearly that 2 to the power 40 is greater than 2 to the power 36. So neither this can be the answer nor these can be the answer. So only possible answer is 3 to the power 21. So this is how divisibility helps us solve questions. These questions which I have solved for you are the questions of CSAT exam 2023. If you have any questions on mathematics, on divisibility, please mention them in the comments so that I can post a reply to the same. Thank you. And next session we will be taking on factorization. We will be discussing on LCM, HCF and much more.